how to analyze textual data using Python, a demonstration. In this demonstration, I will show you some basic operations that you can use either with native Python or with the Spacy package in order to analyze some textual data. Now, an important note here is that I have a very comprehensive reference notebook that you can find in the Python NLP tutorial GitHub repository. This notebook, particularly if you open it up in NB Viewer, will have a very comprehensive overview of examples on how you can deal with a wide variety of problems when it comes to processing textual data with Python. So make sure that you have this file open whenever you're trying to solve the NLP problems later on. Now what I have here is I will use both Python and the Spacy package, and what I will show you is, let's say that I have a data file, just a text file, that's speeches.txt, and that txt file will have a collection of Trump speeches. And the goal will be to analyze these speeches by the president, and then what we would have to do is we would first have to open it up. If you already know where that file is located, you could just open it up, but we can also, just for the sake of it, if we import these packages. Now, whenever you import this is the Spacy package, but I'm just loading in the language model. This is the LG model, so this is why it takes a little while to load. But then what we can do is we can do os.listdir, and if I just run this without any parameters, it's going to take the working directory and look for anything that's in that folder. In this case, the speeches.txt file is located in the data folder. So I would specify that, and then you can see here, well, there's a bunch of different files, but here that speeches.txt file, that's the one I want. So I know I need to go into that data folder. Nowadays with Jupyter Labs, it's very easy to also do that right here, but still sometimes it's useful to have a check for this in your code as well. So we're going to open up this file, and as I discuss in multiple of the reference notebooks, I always recommend to do this with open, with open, I should say. So we do with open, and then we specify where this file lives. So I say it's in the data folder. It's called speeches.txt. And then we give this two pieces of additional information, which is one, we want to read this, so we do R for reading. This means that we have no way of actually modifying the data, which is a desirable property of using the R parameter. And we can specify the encoding just so that Python is not going to get confused about certain encoding characters in this file. So we specify the encoding as UTF-8 or Unicode. And then we do SF. You can call this as anything, but F just stands for file. And then if we were to do file read, F read, it's going to look it up and it's going to open it up and then everything works. But because we don't assign it to anything, it's not actually doing anything. So we say, okay, let's call this a speech text. And then it didn't give us an error, so that's good. It was able to find the file, and then we can get the first 300 characters, I should say. By just kind of almost like a list, but then it would just go character by character. We say speech text and then the first 300. One thing that's interesting to note here is that you see all this weird stuff right here and this \n and all of that. If you were to use a print statement, then all of this disappears. And the reason is that these are kind of these encoding characters that indicate some form of formatting, like a new line or something. Whenever you do a print statement, then these get rendered, if you will, and you can no longer see them. But if you don't, then you will see the raw representation of that. And this is important to notice, because if you just look at this, then you might think, okay, well, I do something in order to get this first element here. But actually what Python is seeing is it's seeing also all these weird characters that you might have to get rid of. You could do this, for example, let's say we want to get rid of all these new line characters. I have many examples in the reference notebook. I could do replace. I want to replace those with nothing, and then you can see that they disappear. And now if I were to print, it's not going to show any new lines anymore, and everything is just going to be on a new line, or it's going to be on the same line. So let's say that we want to count how many times the word great is used. We can do this all with native Python. We can do speech text, and then we can do count great. Now note that this is case sensitive. So if I were to capitalize this, then it's not going to capture many of them. But if I make it minor, then it's going to work. If you don't have to deal with this, then generally what's good, although it can be a little slow, is just do dot lower. That will convert everything to lowercase. And then you can do your count, and then it will work without you having to specify whether it's capitalized or not. We can also apply a regular expression to this. Now, the regular expressions are done by the RE package that's built in with the Python installation. And what we can do is we can specify a regular expression. And a common regular expression for this would be something like really. And then we do a capture group. So we start parentheses to indicate what we would like to capture. If we do dot, that means that can be anything. And then we can do a star to indicate that can be of any length. And then we can do a question mark to indicate that we would like to get the shortest match possible. And then we can specify, well, another space, for example. Now, again, I have a lot of documentation on this, and I will not go in more detail in the lecture recording. But let's say that we figured this out. We've used pythax.org, and we know that this works. Then what you can do is you can do re.findAll, specify the regular expression, specify the string, the text that we would like to search in. And then we can run this. And then, as you can see, there's a lot of different words here that are following the word really. Now, one thing that you might notice is that if you do print speech text, is that it says speech 1 here. And then if we scroll down a little bit, it says speech 2. And then if we scroll even further, here it says speech 3. So there's multiple of these speeches included, and we can even open this up in Jupyter Labs if we wanted to by just clicking this, and then we can inspect it right here as well. Is that what we could do is we could try to split this up into speeches. We could use this, we could use two methods, either basic Python operation, such as speech text split speech. And then what we get is we'll split it up, and then we can see how long this is. So it kind of got 12 elements, but the problem with this is that if the word speech were to occur somewhere in this text, it will also kind of get screwed up. So we're better off using a regular expression that takes into consideration that it's a speech, a space, and then a number. So what we can do is we can then define another regular expression, and we can use re split, which is just the regular expression version of the split command. We specify that, hey, we want to have speech, and then we want to have a space, and we want to have a number. And then we can specify the text that we would like to look in. It's going to take a second. And then it's going to do the same thing. Now, again, you'll see here that it starts with this weird one. That will be simply because we have these weird characters in there, and it's going to split everything. So the first thing that occurs before speech is going to be these weird characters. We could do something along the lines of, can use a list comprehension. I like to use these because they're kind of very space efficient. We can say, well, we want to keep speech for speech in this list if the length of the speech is above 50 characters, because we know a speech has to be at least somewhat long, otherwise it would be a weird speech. And then we run this, and now we can see that we have this working relatively well. So we can say that this is our speech list. And this will indicate that we have 10 speeches. Now, one problem that we do have is that here, if we were to have more than 10 or more than 9 speeches, you will have multiple digits. What you can do is you can specify with these curly brackets that if you do curly brackets and then a comma, just look this up if you want to know more how this works. And this will specify that you can have any amount of digits. So it can be 1 digit, 2 digit, however many digits. We can run this again. We'll see here that this does indeed result in an additional hit. And then if we were to go to speech list 10, for example, we now have another one. And you can see this is on all caps, which is very typical. And we now have split this up. Now, these are basic operations that we use using basic Python. If you want to do something more advanced, like splitting it up into sentences, then generally you'd be better off using Spacy because that's more powerful and more convenient. So let's say we just take a speech 1, just as to make it a little bit easier for us to do these operations. We'll get the first item of that speech list. And then we can convert this into a Spacy object because we imported Spacy here with NLP equals and then the name of the language model .load. So we can do NLP and then we can specify the string that we would like to convert. And then this is going to work. Now, one thing that is usually very convenient is if you do strip, it's going to get rid of any kind of duplicate or any white spaces in the beginning or at the end. So then we do this, and then let's call this NLP speech. And then if we wanted to split this into sentences, we can do NLP speech sense. And now you will see that, like, you initially might think, well, this is a list, so I can just do any list type of thing with it. But it will say here that this is currently a generator. It's not a list. So we would have to explicitly convert it into a list. So we can see there I have 407 sentences. So if we'd say speech, something like this, and we want to get the 10th sentence. Then we get this, they want to work, they want to make the county great. So we now have these different sentences, and we can get any of these sentences out of this. And then you can see it's not perfect because here you can see that this probably went wrong because it starts with a comma, and you might have to do a couple of sanity checks for this. But most of the times, the Spacy sentence segmentation works relatively well, as you can see. We can strip white space out of this, and we can do that using that strip command. We already did that here, so we don't need to do it. We can do this at the sentence level as well. The only thing is that because these are Spacy objects, so we would have to convert it to text first, which you can do, but just realize that this is going to be a Spacy object. It's not going to be the text object. If we want to get the text, the string out of this again, we would have to do .text, and then we have the string, and we can do stuff like lower, or we can just do stuff like strip or whatever. And then the final thing I want to show you, because I think it's cool that this is so easy to do with Spacy, is we can get entities out of this. So let's say we go to sentence 150, and we see, I mean, the euro, China, Mexico, everybody's devaluing. And let's say we want to get all the countries out of this, for example, or at least all named entities. What we can do is we can go through this, and then we can do ents, and it's going to recognize that we have these different entities, but these different entities can actually even be drilled down a little bit more by doing for entity in ents. And then we can do this, but we can also do, and this is a trick that you might find useful, if you just type pass, it's going to run this, but then because it keeps the last one of the loop, we can actually refer to this, which can be convenient if you want to quickly look up some of this documentation, like here. Let's see, which one did I want? Label. Right, so the label, in this case, and the Spacy documentation has all of this information, will tell you what type of entity this is. And GPE stands for geopolitical entity. So we can do print. And then you can see, well, it's figured out that first this is euro, which is a NORP. I assume that's some form of a, also a geographical cluster or something, like if we were to Google this, for example. So if you were to Google this, you would end up at the Spacy documentation. It says NORP stands for nationalities or religion or political groups. So that's the Eurozone. And there's a whole bunch of these different ones. So we see here that this is a nationality or some form of religion, in this case, a nationality. And then China and Mexico are going to be geopolitical entities. We can also do this for a slightly different sentence, because I think 200 be saying something else, and they talk about Syria. So then again, it will extract Syria out of this. But even if I were to create something like a sentence that would be, Tisdakok works at the University of Washington, and then I would convert this into a Spacy object. And then I do entities, and then wallet recognized. It's kind of a common name, so let's just call this something that would be more common, John Smith. Then that worked a little bit better. It doesn't like the fact that Dutch last names have spaces in them, because this is an English language parser, right? So Dutch or any other language is not necessarily going to be parsed correctly. So we could do the same logic that we had right here. So it's going to recognize that John Smith is a person and that the University of Washington is an organization. This is tremendously useful, it's super powerful, and very convenient to use. So with that, I wish you good luck with your NLP problems.